Well, let us do the proof here, cosine rule, and then we proof for an acute angled triangle. So meaning we proof for a case where triangular angles are then less than 90. So cosine rule are a squared, meaning how's that this length a way square. Ilole gonna lay this length squared plus this length squared minus 2 times this length times cos of the opposite angle to A, which is A. Okay, so in a nutshell, this angle, because it has a right angle triangle, we construct the two right angle triangles from this triangle, and then from Tswana we apply the Pythagoras theorem for those two right angle triangles. So the first thing we do is divide this into two right angle triangles, and then we do so by constructing. So let's say here you construct H. So I reconstruct the H, meaning reconstruct the height. So height are something like this. Reconstruct that in such a way that H is perpendicular to the base, because when not perpendicular, then it will form the angles that 90 here. So this will be H. And then if you form those two angles that 90, this get a right angle triangle, let this get a right angle triangle. And then those are the two right angle triangles that you give. Now remember, length C get length here A, B. So something to say. This is our A and this is our B. And then the entire length is C. Now after I construct this H, suppose this line I construct the length intersect at the base at some point D. So then reconstruct the CD, which is our height. And then the length is C from A to B. So RBZ the length, let's let the length here AD to be arbitrary. RBZ X. So if AD is some arbitrary length X, then our D is somewhere here. So this length is X. And the remaining length here, it should be the entire C minus this portion of X. So this length is C minus X. So meaning our DB, come on, this triangle should be C minus X. Okay, so we have two right angle triangles. Let's see regards under this one. Got the right angle triangle, yeah, AD, no, ACD. So this is right angle triangle, and this is A, this is C. This length is that B, this is that arbitrary length, yeah, X, and then come on that H. If we apply the Pythagoras theorem there, Pythagoras theorem says x squared, no, b squared. It says b squared, which is the hypotenuse, should be equals to x squared plus h squared. And then if we make h squared the subject here, this will imply that h squared is equals to b squared minus x squared, because utsafela this y transpose if it's not negative. Okay, now this is h squared from the right angle triangle ACD. Let's do the same the other right angle triangle, yeah, DCB. Now DCB looks something like this, and then here Renali D, here we have C, here we have B, and this length is C minus X, and then this length is our H, this length is A. So more this right angle triangle, the hypotenuse side are A. So if we apply the Pythagoras rule, A squared is equals to Now this length is c minus x, so it should be that c minus x all squared plus h squared. And then if raise this h, the subject, it will h squared is equals to this ray transpose. So it will a squared minus c minus x everything squared. So we have two cases. Let's call this equation 1 and then this equation 2. So h from equation 1 give b squared minus x squared. The same h from equation 2 get a squared minus c minus x all squared. So that can only mean one thing, and that is that the length is a bit dialegan. So because remember h here, dialegan exactly, because these are from this diagram. Get the same h, so dialegan. And if dialegan, I equate this to this because get the h squared the 2. So if we do so, then we can say therefore h squared, well, because h squared elegana le h squared. From equation 1, I have that this h squared give b squared minus x squared. But then from equation 2, I have that the same h squared get a squared minus c minus x everything all squared. Then now I'll multiply out here. I'll break it down this bracket first. So we have b squared minus x squared is equals to a squared minus, if we multiply out here, now c minus x, say 2 times c minus x, because it's c minus x squared. So then rodonally a squared minus, if we multiply out rodonally c squared minus 2cx plus x squared, if we multiply out that side. So b squared minus x squared, right, drop a fella, and again renally b squared minus x squared is equals to a squared. If we multiply this negative sign in, renally minus c squared plus 2cx minus x squared. And then minus x squared, if we multiply positive, so we do cancel an allele, so we can cancel out those x squareds. This you do cancel out this x squared. Then after doing so, Rosalaga b squared is equals to a squared minus c squared plus 2cx. Okay, so at least we have the a squares and b squares and c squares from the well, appear this cosine rule here on, and then later 2 or an leon. And now says you define this x. Now from the cosine rule, we have cos of a here. So if we cos of a, somehow this angle a, and then remerekisa somehow included that x and included that x remerekisa that cos somehow we're grab this cos of a. But then let's check our x again. I define our x again because x is some value arbitrary, and more this rule on arana x anyway here. So I define x again. X is the adjacent side of this right angle triangle. So if we define that x, we can say that cos of a, so cos of this angle, we know that it should be adjacent over the hypotenuse. And then get adjacent over the hypotenuse, so cos of a will be the adjacent side, which is x. So get x over the hypotenuse, which is b. And then from here, if we is that x is the subject of the formula, then we'll multiply both sides by b. So multiply by b, multiply by b. So this you cancel at this, and then e be re sala ka x is equals to b cos of a. So this give the value x, that x will arbitrary. So right now I'm substitute that value x for b cos a. So rona le b squared is equals to a squared minus c squared plus 2c times x. X arona give b cos a, so ilona b cos a. So this give that x arona, this part there b cos a. And then from there, if it's a the subject of the formula, everything you got transpose, because remember we have to show that a squared is equals to that. So if it's a the subject, it's c squared to transpose, and really this 2cb cos a transpose. So then ronale the following. So ronale a squared is equals to ronale b squared this side, so it will not b squared. C had like a positive, so you give b squared plus c squared, and then this part ilona negative because it positive is agamo, so you get that minus 2cb cos of a, and that is that a squared is equals to b squared plus c squared minus 2cb cos a. Well, we'll multiply here, so whether about cb or a bc first, they are Tswana at the end of the day. So yeah, that's that. This is the proof here. Yeah, the cosine rule, which is exactly what we had to prove. So make sure that you go through this video again until you understand Oranzereza. And then yeah, that is that, and thank you for watching.